to begin with, so this reviews everything that was over your homework, so go ahead and work on this. And try to, on number 4, try to do number 4 manually. Okay, you don't, if you don't want to at all, or you're totally lost on that, you don't have to, but attempt 4 and 5 manually. Okay? Okay, so again, all of this really could have been done without your calculator. Dimensions of matrix E. You can tell me what you got. So row by column, so it's what? 3 by 2, right? 3 rows. So 2 by 3 would be wrong, right? Because it's important to have the order correct. So it's 3 by 2. Okay, and then find A plus 2B. So, again, 2B just means multiply B by 2. So that becomes, so you're just distributing, right? A 2 to everything in B. And then A plus 2B, 3 plus 2 is 5, 8 plus 0 is 8, negative 6 plus 0 is negative 6, and 5 plus 2 is 7. Everybody agree with that? Okay. 4C is just, again, distributing 4 to all of C. So we get 20, 8, 12, and 0. Everybody agree with that? Okay, so now D times E, again, first you want to check, can you do it? And D is a 2 by 3. E is a 3 by 2. So can you do it? Yes, you can. And the answer is going to be a 2 by 2, right? So, Casey, does anybody else say absent last class? Okay, so you line them up next to each other in the order you're going to multiply them, and the middle numbers have to match. So if they match, you can do the multiplication, and your answer will be the size of the outside numbers. So the answer matrix here is going to be a 2 by 2. So I'm going to go ahead and set this up, and I'm going to run through this manually for any of you who did it. So we're multiplying D times E. So again, we're looking at the first row of D, multiplying it by the first column of E. So we get 40 plus 2, which is 42, minus 6, which is 36. Everybody agree with that? Okay. Row 1, column 2. Now I'm staying on row 1, going down column 2, negative 5 plus 12, which is 7, plus 15, which is 22. Is that? Okay. Okay, now row 2, column 1 is 8 times 4 is 32, minus 1 plus 0, so 31. Very good. And row 2, column 2 is negative 4, minus 6, plus 0, so negative 10. Okay, so how many did that manually? Did anyone do it manually? Okay, good job. All right, but that's definitely doable that way. And that, again, I won't ever require you to do something manually, but we are going to have a quiz, and that will be the bonus. Just show me the. And what I want to see when you show me that is I would want to see like the little equations that led up to that. You know, like 40 plus 2 minus 6. Okay, so
you always go across and go down?
Yes, the first one in your problem, you only use the rows. You're only going across. And the second one, you're only going down. Okay? Okay, F times B. Answer is, can we do it? No, right? So it's undefined. Because again, F is a 3 by 3. B is a 2 by 2. So if you look at the middle numbers, they don't match. So actually, for this one, you can really say can't do it, can't multiply, dimension mismatch, or just undefined, because multiplication is not defined for that. Okay? Very good? Okay, so now we're going to look at the next section, 12.3. Okay, now, this is a little confusing, this lesson today, because it's just a lot of terminology that may not make a whole lot of sense, but you need to know, I mean, it's the basics of matrices. So it's basic terminology that we're going to learn today, and the next class we're going to use it for just like a division problem. So you can imagine if multiplication is that complicated, division's kind of even more complicated when you're dividing two matrices. So today just kind of sets us up for that. And this is the last thing we're going to learn. Next class, we're going to learn how to use this stuff to solve a simple division problem. And then we're going to have a little review next class and a quiz next Thursday. Okay? So anyway, if today seems a little disjointed, it kind of is. Okay, but we can do it. Can you do it? Yes, you can. Okay, so just a little vocabulary. So a square matrix is really all we're going to be dealing with today. And a square matrix is a matrix with the same number of rows as columns. So just what you think of a square. So, for instance, a 2 by 2, a 3 by 3, 5 by 5, etc. Okay, so square matrix is the same number of rows and columns. Identity matrix is a square matrix with all ones down the main diagonal and all the rest zeros, and zeros everywhere else. Okay, and zeros everywhere else. So what that means is, again, it has to be square. So it cannot be like a 3 by 2, 2 by 5, etc. It has to be square. And the main diagonal always goes from left to right. So like for a 2 by 2, it would be ones here and zeros everywhere else. Okay? For a 3 by 3, it would be ones down this way and zeros everywhere else. Okay? So it cannot be ones going the other direction. Okay? It could not be ones going this way. And it could not be any other numbers, okay? So even if you had like all 2s down here, that's not an identity matrix. If you had, anything else, it has to be this, okay? And what this means, this identity matrix is actually, you want to think about it as like the number 1 in matrix world. Okay, so in other words, we use 1 a lot. In various ways, like to cancel things out, etc. So the number 1 looks like this for a matrix. It's not a matrix of all ones. It's this identity matrix. Okay? All right. Now, and you're going to understand why that's important, hopefully in just a second. Okay, now, multiplicative inverses. Okay, so an inverse, multiplicative inverse matrix is 2 square matrices that multiply to equal the identity matrix. Okay, so to compare this to like real numbers, if we have, let's say I want to say 3 times something equals 1. Because again, I'm saying that the identity matrix is kind of like the number 1. So if I were to come up with 2 numbers and multiply to 1 in the real world, what would I multiply 3 by to make it equal 1? What would I multiply 3 by to make it equal 1? What's that? 1 over 3, right? 1/3. So reciprocals, basically, right? So if I had 2/5 and I wanted to multiply it by something to equal 1, 5/2. So we actually just went through this last chapter, right? For trying to cancel out like the fractional exponents. Okay, so multiplying reciprocals gives you the number 1. So multiplicative inverses are kind of the reciprocals of matrices. Okay, so you can think about them like that. They're not the flip of them, like you don't flip the terms or anything like that. But when you find multiplicative inverses, they perform the same way as like reciprocals do in the real world. Okay? Does that make sense? And again, when you think about it, reciprocals are really important on a division problem, right? Like if you have 3 times x, this is how we're going to actually end up using the next class. If you have like 3 times x equals like 7, how do you solve that? You divide by 3, or you're really multiplying by the reciprocal, right? So that's why this becomes important in matrices, okay? Because it's the only way to really like undo a multiplication, okay? So what we're going to do now is we're going to look at these two problems here. So for each of the following are A and B inverses. Okay, so we're given two matrices. We want to see if they are inverses of each other. Okay, and the way we test that is we see if when we multiply them together, do we get the identity matrix? All right, so I'm going to go ahead and go through this one manually, just to practice it some more. So we have a 2 by 2 and a 2 by 2. So our answer is going to be a 2 by 2, right? So row 1, column 1 is going to be -4 plus 5 gives us a what? -4 plus 5 is a 1, right? Row 1, column 2 is 1 minus 1 gives me a 0. Row 2, column 1, -20 plus 20 is 0, right? And row 2, column 2 is 5 minus 4 gives me 1. So does this give me the identity matrix? Yes. So are they multiplicative inverses of each other? Yes. Okay, so go ahead and try the next one. You can either do it manually or on your calculator. Okay, so I entered these on my calculator. Now, to see if they are multiplicative inverses, right, I'm just going to multiply them together. So I, matrix world, grab A, matrix world, grab B. Now, if I multiply them together, if I get this, they are inverses, right? If I don't, they're not. So if I put that in, and they are. Yes.
How did you try to type in the front?
If you can type them in exactly how they.
You just put 5 divided by 2.
Yeah. So like I could like here, it will change it.
Okay.
To a decimal. Like if I go, if I did 2 divided by 5 and hit enter, it just changed it.
Can you do alpha y equals here?
Alpha, what will it do?
Change it to like a fraction.
Oh, maybe.
I tried it, but it.
I tried doing it.
I've never done that before. Yeah, no, it just changed it to decimal. Okay? All right, so questions about that. So first part of your homework, the worksheet we're going to practice on, because part of the confusion today is all this terminology. But if you're given two matrices and you're asked, are they inverses of each other? Okay, you just multiply them and see if you come up with the number 1. So it's almost like saying, are these two numbers reciprocals, right? And if you multiply them together, you should get the number 1. Okay? All right. Now, next vocabulary word is the determinant. Okay? And determinant determines whether a matrix has an inverse. Okay, so determines whether an inverse has a matrix basically by saying if you find a determinant, the determinant is just a number. And we're going to show you how to find it. If it comes up greater than 0, or actually if it comes up not equal to 0, then the matrix will have an inverse. If it comes up with 0, it doesn't. Okay, so it can be negative, it can be a fraction, it can be a decimal. As long as it's not 0, you could find an inverse for that matrix. If it is 0, you can't. So just like everything in matrix world, you can do it on your calculator, or you can do it manually. The 2 by 2s are really easy to do manually. So I'm going to show you that. Anything greater than that would have to be done on a calculator, or we're not going to learn how to do it manually. So to find it manually on a 2 by 2, if you think about a 2 by 2 matrix using these letters, so if you named it like A, B, C, and D, then the determinant is just taking the diagonals and subtracting them. So it's A times D minus B times C. Okay? So it's actually pretty easy. If we look at this one, to find the determinant, we're going to do 2 times 3, which is 6, minus 4 times 1, which is 4. So the determinant is 2. Okay? So again, if we're asking, could we find an inverse for this matrix? We find the determinant is 2, so yes, we could. Okay? On the next one, if we try to find the determinant, again, we go diagonal, negative 2 times 3 is negative 6, minus the other diagonal, negative 5 times 1. So we get negative 6 minus negative 5, right, which becomes negative 6 plus 5, so negative 1. So if we want to use that to say, could we find an inverse? Yes, we could, because the determinant is non-zero. Okay? So you guys go ahead and try and find the determinants of the next 4 right there. Okay, so what did we get for A? Somebody, Caroline, what did you get for A? 3. So we got 15 minus 12, 3. Everybody agree with that? Okay. Let's see. Sam, Lyden, what did you get for B?
0.
0, right? So negative 2 times 0, 0 minus 0. So this would have no inverse. So if we were going to try to use anything with an inverse for an equation with that matrix, we couldn't. Okay, no inverse. What about the third one? Tia, what'd you get?
I got negative 20.
Negative 21, right? So negative 21 minus 0, negative 21. And Samantha, what'd you get for last one? Negative, yeah, so negative 2 minus 15 gives us negative 17. Okay? Questions about that? All right, so again, it's just a factor that helps you know whether you can find an inverse. Now, on a 3 by 3, there's a way to do it, but it's pretty complicated. So we're going to use a calculator for this one. Okay, so there's a function in the math section of the calculator on the matrix world. So go ahead and enter this in on one of your matrices. Doesn't matter to me which one. Actually, go ahead and enter both of them. Okay, so I entered those as matrix C and D on mine. Okay, so wherever you entered them, you want to put that matrix in it. So to find a determinant, I'm going to go to matrix world, and then now we're actually going to use the math column. So you're going to scroll over to math, okay, and the first option up there is DET, so that stands for determinant. So you want to math and choose determinant, and then go get the matrix where you entered the first one. So for me, that's matrix C. So I go back into matrix world, I choose C, okay, and I hit enter. And 20. So I go into matrix world, I go over to math, okay. This is where I get the function, DET, so I'll pull that out, okay. What's that? Now I'll go ahead and do D. So now I found the determinant of C is 20. I'm going to find the determinant of the matrix that I entered as D. So then I hit 4. And it's negative 48. Okay, so scroll too quiet. Okay, so the determinant of C was 20. So again, it means it has an inverse. Okay, and the determinant of C was negative 48. So again, it has an inverse. Okay? Let's be quiet. So again, this is just restating why we care. It's basically, if the determinant is 0, it does not have an inverse. And again, the inverse is going to allow us to actually divide with this matrix next class. Okay? So that's why it's important. So I want to run through what I'm saving you from here as to how to find the inverse of a matrix. All right, so again, finding the inverse of a matrix is similar to finding the reciprocal of a number. Yeah, Taylor, do you have a question? Okay. So again, to find the inverse of a matrix, you don't have to write this down, okay, but I want you to watch me to show you how manually to do it. All right? So manually, if we wanted to find an inverse, you find the determinant. So the determinant of this was what? Negative 9 minus negative 6, which would give me negative 3, okay? Then you're going to take your matrix, and again, you do not have to write this down. and you, let me think how to do this. You switch, oh, hang on. Okay, so you find the determinant, you switch A and D. So I move I move D into A, I move A into D. You switch A and D, you change the signs, scroll up, it's very important, of B and C. So instead of 6, I get -6. Instead of 1, I get +1. And then you multiply by the reciprocal of your inverse. Okay? Now hang on a second. Hang on. So now if I multiply through by that, I get 1, -2, 1/3, and -1. Okay? So by going through all that, I have found the inverse to this matrix. All right? So that means if I then multiply this times this, I get the identity matrix. Okay? Now, there's an easier way to do it on your calculator. So first of all, I want everybody to go ahead and enter this matrix on your calculator. So pick a letter. Okay, so I entered this as E. I'm going to go back out. Now, to find the matrix, to find the inverse of it, much easier than what I just did. Go ahead and pull it out. So go get it. Okay? Now, through the magic of technology, hit this little button again. Don't hit second matrix, just hit that x to the -1. Okay? And hit enter. And ta-da! Although it made it negative, I must have made a sign change on that. That should be negative. Okay? So again, much easier than what I had to do about rearranging, changing signs, dividing by the determinant. So now this is the inverse of it. So what this is saying is that if I multiply this inverse, right, by my original E, what should I get? What should I get if this is the inverse of this? Then if I multiply them together, I get the number 1 matrix, right? The identity matrix. So let's try that. So this is my inverse. If I just multiply it by E, I don't even have to retype it in, I should get the identity, and I do. Okay? So I know there's a lot that we're looking at right now, different words. Samantha?
Why did you get the differently? Because you got +1 and then you got -1 and then -2 and then there's this 2.
Oh, here, I must have done that wrong somewhere. I mean, I need to look at it more. But what's that? Oh, no, you will never have to do this. No, this is way too complicated. I mean, you all can handle it, but we don't have time to do that. So no, I was just trying to show you how complicated it is. And even I'm going to practice that next time. So no, when you need an inverse of a matrix, which again, we're going to use these more next class, but when you need an inverse, you just want to type in the matrix, bring it up, and type in that little -1 sign, and that will give you the inverse of it. Okay? So go ahead and try these next 3. So enter these on your calculator. In fact, go ahead and enter them. How many do we have? Let's everybody go ahead and enter them in like E, F, and G. Okay? Okay, so after you've entered them, so I entered these as E, F, and G, so hopefully you guys did too, so it makes it a little bit easier to follow. So again, I've got this matrix. I want to find its inverse, right? And when I found the inverse, then I would know if I multiply this by that, I would get the identity matrix, right? So if I want to find the inverse, I'm going to go into matrix, keep it on names, select E, okay? So to find the inverse, I hit the inverse button and enter, and it tells me singular matrix. Okay, so error. So what is it? How can we find out if a matrix should even have an inverse? What do we look for? The determinant, right? The determinant cannot be 0, right? Or it can't have a matrix. if we look at this, what is the determinant of this? Negative 20 minus negative 20, which makes it 0, okay? So this error actually means that this just does not have an inverse, okay? Because the determinant is 0. Okay, so when you get an error trying to find an inverse, one of the first things to check is, does it have a determinant? And it doesn't, okay? So F, if we try to find the inverse of F, again, we go into matrix world, we pick F, we hit inverse, we hit enter, and yes, it does. So the inverse to this matrix is 1, negative 1, negative 1.5, and 2. Okay? And the symbol for inverse is that little negative 1. So if this is matrix F, then F to the negative 1 means inverse is this one. Okay? Now, if we want to find, oh crap, what did I just do? Yeah. Oh, I'm recording, okay. All right, if I want to find, why is it that? Okay, if I want to find the inverse of G, again, I go into G, go into matrix world, pull G, hit inverse, hit enter, and that's the inverse of G. So I can write it like this, G to the negative 1, and it is negative 4, negative 3.5, and 2. Negative 5, negative 5, 3, and 2, 2, negative 1. Okay, so if this is G, this is the inverse of G. If I multiply those two together, so again, if I picked this up and just multiplied it by G, I get the identity matrix. Okay? So I know it's a lot of vocabulary, a lot of strange terminology. The questions about this is all leading up to being able to divide by a matrix next class. Oh, okay. And actually, that's easy. Now, if you understand the terminology, that will not be difficult. But if you think about like reciprocals. Okay? All right, so what I want you to do, the rest of the class and homework is the back side of the puzzle worksheet from last class. So it's called 5.3. And I want you to do 1 through 15 odd. So what you're going to do on those is 1, 3, and 5, you're just determining whether they're inverses. So you're just going to multiply them together and see if you get the identity matrix. On 7, 9, 11, and 13, you're just finding the determinant. So you're just finding a number. And on 15 also, you're just finding a number. And then after that, the book, there's just 4 problems in the book that is actually finding inverses. So again, most of this is calculator. You could do like 1, 3, 7, 9, and 11 by hand, but the rest of it's going to be calculated. Okay? Questions? Okay.